So I hope you had time to think about those examples. Have you solved them? So first example, second, third example. How many have you solved? Or late in the evening, you're tired? All right. Let's try to see what's happening with the first limit. Maybe 2. 2 is what, James? 2 is for which problem here?
Like 2 out of the 3, like the first one and maybe the third one.
Okay, no trouble. So let me remind you of several things, guys. Here, you can see my board. So the first question was limit as x goes to infinity, x tangent of 4x, I believe, right? 4x, 5x, what was that? 4x, yes, I was right. So let's look at this question intuitively, guys. What happens if x goes to infinity, then 4x goes to infinity, yes? So what happens, this is just the angle, right? So as I go to infinity, it means that I rotate around the circle again and again. I'm just looking at this part. Yes, looking at this part, and what happens is that I rotate around the circle. Can you see where is tangent here, guys? So let's say if I open up the angle at some point, I open it up to here, then that's the angle. And then tangent of that value will be this thing here. Yes, that's tangent. Now this line, of course, if I move it a bit further here, let's say, then what will tangent be? Tangent will grow enormously. I'll put it maybe in here. So tangent will grow enormously. It would be somewhere here. Actually farther, right? You see that? That's the tangent, yes, guys? And as I approach, the angle approaches 90, it approaches infinity, then here it's negative, then positive. Basically, this structure oscillates. It goes through all numbers all the time. As I push x on, that means I'm just rotating again and again. I'm rotating around the circle. Again and again and again. That's what happens when I change the angle. Maybe if you don't think of the, see, I mean here the angle. Don't forget about x. This just means angle. Yes. So tangent here will jump through all sorts of values. Now sometimes it will be equal to 0, correct? But x is just growing to infinity. So whatever x is, sometimes it's 0, sometimes it's other numbers. The limit simply does not exist. So this limit does not exist because, for instance, tangent will repeatedly be equal to 0. 0 times any number is 0, right? And then tangent repeatedly will be equal to 1. So 1 times a big number is huge, right? So it just oscillates. So that's divergence by oscillation. Does not exist. Good? Everybody clear? You just kind of easily picture it.
So the answer to the first problem is infinity?
No, the answer to the first problem does not exist.
Oh, wow.
Because at some instances, let's say x will be such that it will be a multiple of 2 pi. 4x will be a multiple of 2 pi, and then tangent is 0. And x is large number, so 0 times a large number is still 0. So sometimes this expression is equal to 0. Sometimes this expression is equal to infinity. Sometimes this expression is equal to all the numbers in between. This expression will oscillate through all real numbers all the time. Do you understand? Next question is what was that? It was 1 plus sine 5t to the power of 1 over tangent 25t. So we want to know what is limit as t goes to 0 of 1 plus tangent of 5t. Was it 5t? Yeah, sine of 5t, sorry. Raised to the power of 1 over tangent 25t. Yes? So what happens if the angle t is very small, and then 5t is very small, and sine is not doing anything to it? Do you agree? You remember this limit. So here you have this limit as t goes to 0 of sine t over t equals to 1. Interpretation is that numerator and denominator are essentially the same. That's how you get limit 1. Yes? Numerator and denominator essentially the same. And that means that sine of t is not very different from t. I can delete it and just write 5t here. And tangent is doing the same thing, because we know that limit as t goes to 0 of tangent of 25t over, not of 25t, let's say of simply t, divided by t equal to 1 as well. We know this limit, right? It's equal to 1. That means that tangent of an angle divided by the angle when the angle is small is essentially the same. So that limit is a limit where t goes to 0, 1 plus 5t raised to the power of 1 over 25t. Do you understand this? So you look like you are just recharging, guys. Do you see what I'm saying? And what is that limit equal to? What is this equal to? So write in the comments, did you understand the explanation so far, guys? I want to know where you are at. Please do that quickly. Okay. So you use routinely this concept here, right? So then what next do I see here? So not only you guys, it must be not passive understanding. You see, true understanding means that you can come up with this on the spot yourself. So next thing, no, Alex, cosine x over x is not going to be equal to 1 when x approaches 0, because cosine will become as long as 1 and x becomes close to 0. So this limit does not exist. Make sense? So what we have here is, this is the same thing as limit where t goes to 0 of 1 plus 5t. And next I make another observation. 1.22 for, okay, but that's an approximation. So then to what power? To the power, here I notice I want to have the power 1 over 5t. And then there is the extra 1 over 5. Why do I want it? It's because I recognize another pattern here, which I hope you do. You see? This is the pattern. The pattern is simply that if I have 1 plus a box to the power of 1 over a box, that approaches to e if box goes to 0. That's the definition of the exponential. Do you remember that? We talk about limits, we have this particular pattern. That is E. If you don't know that, guys, brush up. So in particular, what am I getting? In particular, I see that my answer is, this is e to the power of 1 over 5. So it's e to the power of 1 over 5. That's the solution. Next question is this. Y goes to 0, tangent of pi over 4 plus sine y minus 1 over y. Yes, Carolina? Type 2. Okay, why not? But you see, especially if you stay with me in office, I can give you lots of such practice. So tell me, please, what is this limit? Limit as y goes to infinity of 1 plus 1 over e to the y raised to the power of 1 over raised to the power, I'm sorry, of e to the y.
Hello. Did you call me? Okay.
What is this limit? Okay, good. One person sees it. What about the rest of you? Okay, second. All right, so a few of you notice, okay, so how do you do that? As y goes to infinity, exponential clearly is increasing. So what you see is this and that, they go to infinity. So it is exactly of the right pattern to equal e. You with me? Here is another one. Limit as y goes to 0 of 1 plus cosine of y minus 1 divided by y raised to the power of y divided by cosine y minus 1. What is that? Okay, Nassim says 1. What about the rest of you? Wouldn't it does not exist? Maybe. Alisa says doesn't exist. We're playing peekaboo. Do you see, guys? That's pretty much what this game is. It's peekaboo. Do you recognize what it is or not? Okay, good. So, only one person? Let me ask you this, guys. What is limit y going to 0 of cosine y minus 1 over y? What is this? It is, the answer is 0, but why is it 0? Because this is just the derivative of cosine x, where x equals 0. Do you all see that? It's the definition of the derivative at 0. Yes? Which is minus sine 0 if I know the derivative, which is 0. Now what's the pattern? If I see 1 plus a box that goes to 0, raised to the reciprocal of the box, that goes to e. That's it. The answer is e. Same thing, exactly the same thing. Do you see that? What did I do? Here is what I do with my exactly. So here is what I do. I box it in, and then I realize that what this thing is, it's 1 over the box. It's the reciprocal. That's it. So I right away know that the answer is e. You with me? Good. I'm a little sleepy, so you know, you have to give me the excitement. All right. So what about this one? Limit. Let me just do it in black. So limit where y goes to 0 of tangent of pi over 4 plus sine y minus 1 divided by y. What is that equal to? You see, guys, how do you solve this particular problem?
can you say that the sine times y is going toward 0? So because sine y over y, you can cross that out.
So yes, you are there, Karolinushka, but exactly what's going on. So first, before you solve it, do you recognize what is this limit? What is this limit?
Is it the limit as t goes to 0, sine t over t equals 1?
But you see, it's inside of tangent. You see, this is inside of tangent.
Oh, okay, sorry.
No trouble.
Sorry.
No trouble. Do you recognize this limit? Do you recognize this limit? You say yes. So what is that limit?
Isn't it sine y over y equals 1?
But it's sitting inside of the belly of tangent. How do you access sine y over y? So so Nassim says 2. Interesting. All right, guys. So exactly. So this is, let's look at it, guys. When y goes to 0, sine of y is the same as y. Do you agree? Sine of y is the same as y. I can do it, if you don't believe me, in 2 ways. So I see this limit. You see, I can drop the sign because it doesn't do anything there. Minus 1 divided by y. And what is this? This is the definition of the derivative of tangent x at x equal to pi over 4. Do you recognize it? I just use y instead of h. So that is simply derivative of tangent is secant squared at pi over 4. Now secant of pi over 4 is root 2. So this is root 2 squared, or simply 2. The answer is 2. This limit equals to 2. So again, guys, it's a peekaboo, right? Close your eyes. Or where did you go? This is what we're doing here. All right, what about this one? Cosine z over z minus pi over 2 as z goes to pi over 2. What is this limit and why? What's going on? No, you know this? So Nassim says 0. Okay, interesting. Before you calculate, guys, before you solve it, ask yourself, what is it? What is someone trying to do here? You are anticipating it, right? It, just like I mentioned, when you are trying to catch a ball, I don't know, I never caught any balls, but I imagine you run in the direction where you expect the ball to be, not where it is. So similar here. Yes, you are trying to figure out what is somebody trying to do, because if you understand what they're trying to do, you might be able to do it better. So what is somebody trying to do here? Okay, Wu, you just made one small mistake. Otherwise, why is it the quotient rule, Carolina? What is this directly? What is someone trying to do? Understand this once, guys, and if you see that, it's really the same question all the time. Yes, Fu, you got it. You got it, Fu. Look at it, guys. Let me write it again. Limit as z goes to pi over 2, cosine z divided by z minus pi over 2. Doesn't it look familiar? What is cosine of pi over 2? It's 0. Denominator is 0. Whenever you see 0 divided by 0, you think, aha, derivative. Definition of the derivative. Yes? What is the derivative about, right? So here is how you can you can tell. It is limit as z goes to pi over 2. This tells you what function. So it's cosine of z minus, we know that cosine at pi over 2 is 0. So it's cosine of pi over 2 divided by z minus pi over 2. Yes? Do you see now? What is this defining? It's the derivative of what function and at what point? It's the definition of the derivative that you have to recognize. All the time, it's the same thing. It's the definition of the derivative of what function and at what point. Please write in the comments or speak. Why degrees? I'm asking what's the derivative. It's the definition of the derivative. Do you understand, guys? Or you forget? You solved the question, for. I'm asking, this is what? This, in your thought, you right away look at it and say, aha, someone was trying to take the derivative of what function? No one? Come on. What function? Derivative of what function is this? Cosinus. Exactly. At what point? Yes, two people. At what point? Pi over 2. Thank you. Finally, it's the derivative of cosine x, where x equal to pi over 2. You see, if you were to write this formula, by definition, that's what you get. What is derivative of cosine? Minus sine at pi over 2. What sine of pi over 2? It's 1. So the answer is very simply, it's minus 1. You see, you realize that somebody is just doing the definition. It's just minus 1, nothing more. Schmarotzen.
What does that mean in German?
You don't want to know.
I think it means like you're like super frustrated, like a cuss word.
It's not a curse word, but yes. You want me to curse you in German?
No, you're a nice guy.
Yeah, I am a nice guy, but my
If
patience
treated
is against him.
respect and vice versa, then yeah.
Let's see. Explain what again? The limit? Yeah, I'll explain the limit. Don't worry. Let's do a few more questions, guys. Let's do the squeeze theorem, and then we will get to the derivative thingy again. I'm very worried. You see, we talk about it so many times, and I hope you will remember it by the final. But I hope you will remember it for the rest of your life. Really, that's what I would be very happy to achieve, right? So that you will just realize it once. So now, have you ever tried to capture a cockroach? Has it ever happened to you that you are in the kitchen and you're trying to smack down a cockroach? Well, if not, then you haven't been in my kitchen, right? That's why I know the squeeze theorem so very well. So what you have is, you imagine that you take a cockroach and you tie to the cockroach a pencil. And the cockroach is running around and tracing a curve. Yes? So now I want to know what is going to be, well, basically I want to trap the cockroach near the position A. So what do? Imagine that as the cockroach is moving, I have this finger is keeping in sync along the x-axis. So the position of the cockroach along the x-axis is always matched by my lower finger. You understand what I mean? So the cockroach is running like this, and I always keep my finger right below it on the x-axis. You understand what I mean, guys? You have to now try to imagine something.
So basically, it's like a tangent line in a way.
Not necessarily a tangent line here. I'm just saying the x-axis are kept the same. Okay. Good. So, oh my God, I'm losing people. I have 27. Now it's 26. What's happening here? What is happening here? Okay. So
Probably they have internet connections. Maybe that's why.
Okay, I hope so, because I get paranoid, you know. Maybe it's because of the sweet lead that I'm eating in my house, or because I do not see your students, right? So here is what's happening. Look at me, guys. Do you see that? Can you imagine that the cockroach is running on the table? And can you imagine that I am somehow able to flank it from below? Maybe I'm not matching the altitude, but I'm always matching the x-axis coordinate, right? So the x-axis coordinate is always matched. Yes? Can you see that? Here. Here is.
Are you saying that's the table? Sorry.
That's the table, yes. So that's the table. So here is the cockroach running around. I'm always matching the longitude of the table, right? My hand, every time you see a cockroach, let's say the cockroach is here. Now my finger will be here. You understand? Cockroach is here, my finger is here on the curve. I haven't caught it because my finger is not touching the cockroach, but the x coordinate is matching. Are you understanding? Good? Yes, guys? And with my other hand, I do the matching from above. Now, you see, that's called the squeeze theorem. If I'm able to move my fingers together at position A, the cockroach has nowhere to escape because he is flanked from the top and from the bottom. And the altitude that he is able to control is diminishing. Yes? Are you with me?
Eventually your fingers will touch it.
Well, touching it's in the limit. Yes, I'm gonna touch the cockroach right over here. I had to do it. So I even had this guy, and he was terrified. He was a huge guy. Was my bodyguard, right? He would always say that, you know, somebody gives you problems in school, I will beat them up, right? I called him Gerasim because he didn't speak too much, but he was very beefy, but afraid of cockroaches. I took care of his cockroaches. So you see here, you have no idea what I just said, of course. I just like, what is this insane person talking about? Yes, Rachel, but yes, you were not even entertained because like, what is he talking about? What Gerasim? What is that thing? You should read this book. It's a great book by Nekrasov. Why did Gerasim drown Mumu? I will never understand. So here you see that that's where the cockroach is trapped. So here G is the lower function, K is the upper function. So you see, what I have to ensure to be able to apply the squeeze theorem is somehow this bad cockroach function has to be flanked from below and from above. The fact that we have X here, the same point, that means that that I'm matching the X coordinate. Yes, I'm matching the X coordinate. So here is a very simple example of how the squeeze theorem is supposed to work. So do you see that sine of 1 over x times x squared is perhaps not an immediately obvious limit? Yes, maybe why not immediately obvious? Because as I make x close to 0, 1 over x gets large, and then sine oscillates wildly between -1 and 1. But the oscillation is dampened by x squared. So here is how I construct the squeeze. So sine of any angle is always between 1 and -1, possibly equal to 1 or -1. You agree? You see this? Anywhere in between. So if I multiply everything by x squared, the original function is flanked on the left from x squared minus x squared, and on the right by x squared. Each of those functions are collapsed to 0, which means the middle, the cockroach function, is collapsed to 0. You with me? Now here is another example of how the squeeze theorem is working. You see, we have 2 times x minus 2 to the 4th, sine of 1 over x minus 2, cosine of 1 over x minus 2, and x goes to 2. So what happens here is I can, for instance, squeeze sine times cosine is still some number between 1 and -1. Do you agree? So this entire expression is between 1 and -1, and the expression I multiply by goes to 0. So I have, this is between -1 and 1, multiplying it by 2 times x minus 2, I get that the function for which I try to calculate limit is flanked on the left by a function I know goes to 0, and by the right by a function that goes to 0. And I know that the limit is 0 because of it again. Good? So those are trivial examples of squeeze theorem. Here is one more example, right? So 10 times x minus 1 squared times e to the x tangent pi over 4x cosine 1 over x minus 1 plus 5. So I said g is this thing, but truly you look at this, right? So cosine is a value between -1 and 1, and everything else here, this g, whatever it is, it's going to 0, because you see this will go to 0. It will be going to e to the 1. This will, sorry, it will go to, this will go to tangent of pi over 4, which is 1. This will go e to the 1, but this part will go to 0. So whatever is underlined as g, this entire expression will go to 0. So all I have to notice is that 10 times cosine is between -10 and 10. And so when I multiply by what remains, it will go to 0, okay? And then there is a plus 5. So the answer is simply plus 5. Good? Now, yes, wait, I'm waiting. What do you want to see? Cosine, well, look at it. It's cosine of 1 over x minus 1. So when x is close to 1, I'm dividing essentially by 0, which means I'm getting cosine of infinity. Okay? So those are very, very trivial applications of squeeze theorem. Most of the important applications are very hard to come by. It's not easy to really realize how to use it, because you have to ensure that you have a top function and a bottom function that trace the cockroach on the x-axis, and they are narrowing to the same point. You understand? So let's move on. So this lecture, again, I will, because of lack of time, I will not go through it, at least not in class, but I do hope that you realize what I'm trying to do here. I hope against hope. So I always hear questions, or at least see comments that I make things more difficult than they are. right? I mean, there's always some people that say that. Maybe they are correct, maybe they are not correct. What I can tell you is this. If you can solve the physics questions in the book that I have on my website, then you can say that you are correct. But if you think that I make things very difficult and you cannot solve those questions, then you are wrong. What is calculus? It's not these stupid questions that we ask here. It's not even those limit questions. Here is the way it appears in physics. Suppose that that you are trying to stop a motorcycle by, it's a motorcycle, it's running on high gear, and it's connected to a chain, and you're pulling at it. You're not going to be very successful, most likely. Yes, the motorcycle will pull you away. It has many horsepowers or something, right? But somehow you will be very effective if you wrap it around, let's say, a tree trunk. And notice you didn't tie it around. You just wrap it around. Here is you, and here is the motorcycle. You understand? So you're pulling it like this. Why are you suddenly able to stop the motorcycle this way and not before? So you see, here is the way I would, that's my explanation. Maybe if you can come up with an easier way to get at the solution, right? So what I do is I look at the tree trunk. I imagine it's perfect, when its cross section is perfect circle. And under high zoom, I imagine that the edges are just straight line segments. And then when I analyze the system, I do some basic physics on a small piece here, and I come up with formulas that look like this. You understand? So after having this insight, after having all this idea, I actually come up with formulas that look like this. And what should that remind you of? That should remind you of what? This formula, look at it. It should remind you of one thing. What is that one thing? Hopefully it's not that you're getting an F. What does it remind us? Pavlini glass. Okay, so the derivative. I'm not asking you what it's equal to, guys. You're getting way ahead of yourselves. I am just interested in knowing, do you recognize what this might be? You understand? You look at it and right away something pops in your mind and you think, aha, this must be a derivative. And maybe not exactly, but I can make it look like a derivative, and blah, 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 blah. We can talk about it if you want at some point. I just, experience tells me that it's a waste of time to do it in class. So yeah, so you understand, this is basically one basic problem in physics. So if you cannot solve this problem a better way than then I'm not making it too complicated. I'm in fact making it hopelessly simple. You see, you do not have a question, solve the derivative of something, right? I want you to be able to think about ideas using calculus. And what ends up happening, let me tell you why the tree trunk is helping you, is that the tree trunk using friction ends up amplifying your force exponentially. You understand? You can be a weak person, but wrap it around a big enough tree trunk, it will amplify your force exponentially. You understand? That's the conclusion that you get here. Now, again, I wish that you would not be able to leave this classroom without looking through it. You see, these trigonometric limits, I talk about rigorously. How do I know that cosine h minus 1 over h as h goes to 0 equals to 0? I give a proof that is rigorous and I use Squeeze Theorem. Here I use the Squeeze Theorem. I then do the same thing for sine. You understand? I show you how to do the Squeeze Theorem and do the same for sine. And if you decide at some point, at some point can be very soon in the future. You understand? We can have this lecture, we can record it, we can do it in office hours if you care. But of course, best if you first read it on your own. Okay, so I need to know, although I recognize that this is the derivative of cosine at 0, I do not know the derivative of cosine at 0 before I can explain what is this limit, and before I can explain the corresponding limit for sine. Do you understand it, guys? Logically, I do not know that the derivative of cosine is minus sine until I know the derivatives at 0 for both cosine and sine, what they are in the limit form. Good. So I gave you intuitive reasoning why sine h over h should be equal to 1, because sine h is the vertical red segment. You remember it, yes, guys? Sine h is the vertical red segment. I played you a video, for goodness sake. And the arc is becoming the same length. That's why that limit intuitively should be 1. For cosine, intuition is slightly less convincing, but I gave you intuition for cosine as well, I hope. But it's not enough. I would like you to, of course, know the explanation rigorously. Wonderful. Let's now, we finished all the material we need for exam number 1. Let me tell you about it.